Welcome back. I've spoke to all of you about the heating curve and the phase diagram, and I have worked out a few problems. But what I did not mention, and I would like to take the time to talk about now, is to really know if you have a conceptual understanding of what is happening between the heating curve and the phase changes. Okay, so as you could see, I have the heating curve on the left hand side here, and then the phase change diagram on the right side. Okay, first, whenever you read a graph in science, you need to know what is your y-axis and what is your x-axis. The figure on the left side, which is the heating curve, you have your temperature in the y-axis and the time is in the x-axis. Okay, what does that mean is, as time progresses, the substance goes from one phase to the other. Okay, similarly, on the right side where we have the phase changes, we have the y-axis is pressure and the x-axis is temperature. That is, either you increase the temperature and you see what happens to the pressure, and in that case what happens to the three phases, or you can reduce the temperature and see what happens to the pressure, and under those pressure changes what happens to the three phases: solid, liquid, and gas. All right, that's kind of what I mentioned in my previous video when we worked out a problem. Now I'd like to take the time to see if you have a conceptual understanding, not just mathematical understanding of the concept of heating curve and phase changes, but more of a conceptual understanding. All right, so if you remember the heating curve, between A and B, we have just solid. Okay, nothing's happening because this is right about here is 0 degrees. Okay, right? So between A and B, it's purely solid. Okay, now between B and C is where the transformation happens. Now at B, it's purely solid. At C, it's purely liquid. Okay. Between B and C, you have both solid and liquid. That is, when you go from B to C, okay, it is basically melting, right? Whereas when you go back from C to B, that's freezing, right? So whenever you see that a flat line, that means more than one phase exists in that, all right, which is better indicated is right here. So on the line, okay, is this B/C. Okay, right on the line is B/C, that is both solid and liquid is existing. Okay, if you go to one side, which is if you go to the left of this line, then we're between A and B, and if you go to the right of this line, which is above C. So whenever it's a flat line, you have a combination of phases, that is more than one phase exists. So here between C and D is when you're actually you're supplying heat. Okay, you're supplying heat. For instance, you're trying to boil a pot of water. This is your pot of water that's at room temperature, and you're continuing to supply heat. And then at D is when you start to boil. Okay, which is at 100 degrees. Okay, so here, whenever you have a steep curve, you only have one phase. Okay, you have just liquid. Okay, and then here, between here and here, is you have a combination of liquid and gas. Okay, because as you see, when you heat and you put like a plate or something on top of, if provided, it will be easier to see if you actually use a glass beaker or something, so you can see through. The process from D to E is, I've mentioned earlier, it is vaporization, right? and E to D is condensation. Okay, so again, in this flat region, you have a combination of liquid and gas, and between E and F, you only have gas, because at this point, like, you've supplied enough heat that the liquid is now going completely into the vapor phase. So that's the difference between, say, you have a beaker that's open and you contain water, and you heat it. Okay, and you have another beaker that's covered. Okay, you notice that this condition, all of the liquid, okay, water that's in the liquid, completely goes into the vapor phase. Okay, whereas when you cover it, that means whatever is evaporating is condensing back, provided the seal is really tight, that none of the steam is getting out. Then this process of gas going to liquid and liquid going to gas is happening, and that's kind of this phase right here. All right, so now if I ask you a conceptual question, say the phase corresponding to B and C, where is it on here? Okay, or say the phase, question is the phase corresponding to the region CD. Okay, phase correspond on the phase curve, on the heating curve. Okay, this is the heating curve. Okay, phase corresponding to the region CD on the heating curve. What does this correspond to? What does this region correspond to on the phase diagram? Okay. Okay. We know between C and D only liquid happens, right? So if I call this as, say, 1, this is 2 on the line, say this is 3, this is 4 on the line, this is 5, and say this is 6. What I'm asking is, the region CD on the heating curve, what does this correspond to? On which one of the Roman numeral exactly matches the region CD on the heating curve to that on the phase diagram? Well, we know between C and D, water only exists in the liquid phase, right? So it would have to be just 3. But what if I ask you, what region in BC corresponds to the region on the phase diagram? Well, between B and C, right? BC on the heating curve corresponds to solid/liquid, right? So that means, as I said, if you have both solid and liquid, that means you're right on the line, not on one side or the other. So this is on the heating curve, right? So what does that corresponds to? The phase diagram would be the Roman numeral that corresponds to that would be, well, between B and C, I have both solid and liquid. So on the phase diagram, if I go to 1, that is purely solid. If I go to 3, that's purely liquid. Only 2 corresponds to the line, which is a combination of 2 phases. So that would be 2. All right. Similarly, say I ask you the heating curve region CD or DE, okay, contains both liquid and gas, right? What does that corresponds to on the phase diagram? Which Roman numeral better represents this liquid/gas combination? Well, liquid is here, gas is here. This is the line that separates liquid and gas, not this. This is solid and gas. This is liquid and gas. So we have both liquid and gas, so the Roman numeral is 4. All right. This is very, very important because knowing this will help you with the math, or knowing the math will help you with this concept. Okay, now this is definitely more conceptual. As you see, I did not do any type of mathematical calculations here to understand the concept. So this is definitely much more conceptually oriented or qualitatively oriented versus quantitative, which is just doing math problems. All right, so this is very, very important. And I guess this is where we conclude the entire larger topic of intermolecular forces. So stay tuned for gas laws. All right.